Hello everyone. Welcome back to Yoke Thermal Guru, your go-to channel for everything about thermocouples, RTDs, and temperature measurement. In today's video, we are going to dive deep into a very important concept of thermocouples, the cold junction. Understanding these two is the key to mastering how thermocouples actually work. So let's get started. What is the hot junction? The hot junction is the point where the two different metals of a thermocouple are joined together. This is the part of the thermocouple that is exposed to the temperature you want to measure. When this junction experiences heat or cold, a voltage is generated due to the Seebeck effect. The magnitude of this voltage depends on the temperature difference between the hot junction and the reference point, which is the cold junction. Right pointing finger emoji. In simple words, the hot junction is the sensing tip of the thermocouple. For example, if you insert a K-type thermocouple into a furnace, the tip inside the furnace is the hot junction. What is the cold junction? Now, here's the important part, the cold junction. The cold junction is the other end of the thermocouple wires, where they connect to the measuring instrument, such as a temperature controller or a digital display. In the early days, this was literally kept at 0 degrees Celsius using an ice bath for accurate reference. That's why it's called the cold junction. But in modern systems, we don't use ice baths anymore. Instead, we use cold junction compensation, CJC, circuits inside the instrument. These circuits measure the temperature at the connection point and adjust the reading automatically. Right pointing finger emoji. In short, the cold junction acts as the reference point against which the hot junction temperature is calculated. Why do we need cold junction compensation? A thermocouple doesn't measure the absolute temperature at the hot junction. Instead, it measures the temperature difference between the hot junction and the cold junction. So, if the cold junction is at 25 degrees Celsius and the hot junction is at 225 degrees Celsius, the thermocouple generates a voltage corresponding to 200 degrees Celsius difference. The instrument then adds back the actual cold junction temperature, 25 degrees Celsius in this case, to give you the true hot junction temperature,
225 degrees Celsius. Without cold junction compensation, the readings would always be wrong.
Example for better understanding. Imagine you're using a thermocouple to measure the temperature of a boiler. The tip inside the boiler is the hot junction. The other end connected to your display or controller is the cold junction. Your instrument automatically compensates for the cold junction temperature so that you get an accurate reading of the boiler temperature. So that's the in-depth explanation of thermocouple cold junction and hot junction. I hope this cleared your doubts and gave you a deeper understanding of how thermocouples actually work. In our next video, we will explore 3 types of primary junctions, why it's so important for accuracy. So make sure to subscribe and hit the bell icon so you don't miss it. Thanks for watching and I'll see you in the next video.